Okay, so now transformations of functions, right? We've got all these parent functions that we just studied. Now, how can we do stuff to them? How can we move them around in the XY plane? How could we reflect them vertically? How could we stretch and compress them vertically? How can we do all that stuff so we can make different versions of those functions? Let's explore that a little bit. Let's talk about translations, right? So going back to geometry, remember, to translate means to slide or to move, right? So we want to be able to, let's talk about how we can do some translations of our parent graph. Okay, so first of all, we want to answer the question, what happens if I add a number to x inside the function, or I subtract a number from x inside the function, or if I add a number outside of the function or subtract a number outside of the function? We want to see what happens there. Okay, so let's take a look. I got a couple Desmos documents built, and I will put a document in Google Classroom that'll just have links to all this stuff we're about to look at if you want to go back to it. Okay, so I'll just make that big. Okay, so here we've got this, look what we've got, the graph of our parent function, p of x, p for parent. So p of x equals the absolute value of x, right? That looks familiar. That's one of our parent graphs that we talked about, our parent functions that we talked about a couple days ago, right? Okay, what we want to do here now is we want to make a substitution. We're going to substitute, I'm going to create another graph, f of x, and f of x is going to equal the absolute value of x minus h. Okay, so I'm going to subtract some value h from the function, okay? And we're going to see what happens. Now I'm going to turn this off for a second. What's going to happen? I'm going to dial in a value of h. If h is 0, then it's the same thing as my parent graph, right? I haven't done anything to it. X minus 0 is the same as x. So that's really just the absolute value of x. It looks exactly like my green parent graph. But what's going to happen like if I let h equal 4? So I'm going to subtract 4 from x inside of the function. What's your prediction? What do you think is going to happen there? If I subtract 4 from x inside of the function, just make a guess. You might be wrong. It's all right if you're wrong. I mean, you may have never seen this before, so it might go down. There's a prediction. It might go down. Okay, that's one possibility. Anybody else got a different possibility? Anybody else want to make a guess here? No? Okay, everyone must think it's going down. Well, let's see if that's a good guess. Let's try it. So if I let h equal 4, and I'm subtracting 4 inside the function, what's it do? Oh, what'd it do? Didn't go down. It did probably the last thing you would think. It went to the right. If whatever number I subtract from x inside of the function, that's giving me the horizontal translation. It's telling me how far am I moving this thing to the right. So if I have the absolute value of x minus 4, I'm moving it to the right by 4. And look, that's what we did. Notice all of the y coordinates stayed the same, but the x coordinates all increased by 4, right? Okay, so now what if I subtract negative 3? What's that going to do? So now I've got the absolute value of x minus negative 3. If I subtract a negative, that's just like adding, right? Everybody agree? So if I have something like the absolute value of x plus 3, same thing as x minus negative 3, what do you think that's going to do? Type in chat. Let's make a guess. Okay, I'm seeing some people signing. That's good. I haven't heard from very many people, though. I want some guesses from people on this. Doesn't matter if you're wrong. Makes no difference. We're just starting this. when h was positive 4, when I subtracted a positive 4, it went to the right by 4. What if I'm subtracting a negative 3? Okay. I'm getting some guesses. Maybe it goes to the left. Let's try it. It does. Look at that. Okay. Now, keep in mind here, what we've got on this, I'm going to make another graph here on top of this so you can see this, right? I'm subtracting negative 3. So that'd be like saying, let's call it g of x equals the absolute value of x minus negative 3 is x plus 3. Look at that, right? Right? That's what we did, isn't it? Right? The absolute value of x plus 3 means that we've subtracted a negative 3. So the value of h is negative 3. So we went left by 3. That one's a little bit counterintuitive, isn't it? Right? Let's try a couple from scratch on this one. Let's see here. I'm going to do a new blank graph. So here's my parent graph again. Absolute value of x is my parent graph. And let's just put, the coordinates of the vertex so we can track what's going on. Oops. Okay, there's my parent graph, right? I'm going to do a new graph now. Okay, and I'm going to do the absolute value of x plus 7. Okay, you guys type in chat. What's that going to do? What's that going to do to my red parent graph? Got to hear from everybody on this one. If I'm not hearing from you on this one, I'm assuming that, so tell me which direction it's going and how far. Okay. I got another way we could do this. Here, we can do it anonymously through a poll. Let's do this. Hey, everybody vote real quick. It's anonymous. Everybody's got to vote. Only got 13 votes. I need lots more votes. Everybody vote. Everybody's got to vote. You got to weigh in. It's all anonymous. Quickly. Oh, it's dominant. Why? It's a landslide. Let's see if democracy works in math. Let's check it out and see. So 7 units to the right, everybody's saying. Oh my gosh, didn't work. It went 7 units left. Yeah, that's right. Noah had it right. He was the one. Remember, it's the number that we're subtracting from x that's telling us how far to the right we're going. So we subtracted a negative 7. This is a confusing one, right? When you add or subtract a number inside the function, it's always the opposite of what it initially seems like, right? So if you're adding a number to x inside the function, you're actually going left, not right by that amount. And if you subtract a number, you're going left by that. Or sorry, other way around. If you add a number, you're going left instead of right. There we go. If you subtract a number from x, you're going right instead of left. Okay? Let's try another one. So now I'm going to change this to, okay, let's see. Let's end the poll, new poll. How about that one? Everybody's got to vote. Come on now. It's anonymous. Everybody vote. Go to the poll and vote. Need more votes. Come on now. Now everybody's voting. This isn't great participation. I'm going to start making you turn cameras on if you can't participate. Come on now. Better get some votes. Ooh, that's a sorry showing, but I'll put it up. Okay, there's the votes. This turned out better because look what happens. It does go right by 5, doesn't it? Right? So again, you're subtracting from x the amount that it's moving to the right. Okay, it's the opposite of what you'd think. Okay? All right. So in other words, if I'm adding a number h to x inside the function, I'm actually going left by h units. If I subtract a number from x inside the function, I'm going right by that amount. Okay, what do you think happens here? What do you think happens if I add or subtract a number outside of the function? Let's take a look at that. Okay, so here's our parent graph again. P of x equals the absolute value of x. And now we're going to add the number k outside of the function. So what if we add, for example, what if we add 4 to the function there, outside? What do you think that's going to do? Say it in chat real quick. What do you think that's going to do? So I've got the absolute value of x plus 4. That's what I'm plugging in for k. So plus 4. What do you think that's going to do? The difference here is I'm adding the number outside of the function, not to x inside the function. I'm getting lots of going up. Let's check it out and see. It did, right? It went up. Went up by 4. Notice that the x coordinates of the points all stayed the same, but the y coordinates increased, right? So as I change the value of k, look what happens. It's just telling me how much am I translating vertically. Well, what if I make k negative? So if I have the absolute value of x plus negative 4, so the absolute value of x minus 4, yeah, it makes sense. I go down by 4 then, don't I? So this one follows your common sense reasoning. If you add a number outside, you go up. That you translate up that amount. If you subtract a number outside of the function, that's how far you're going down. Okay? So f of x plus k means we're going up by k units. F of x minus k means we're going down by k units. Okay, now let's look at both of these together. Okay? So how about if we do... let's do that. Okay. Okay, so this time we've got our parent function f of x equals x squared, right? That made a parabola, didn't it? Okay. I'm going to make a new function here. G of x equals the quantity x plus 3 squared minus 4. I want you guys to tell me, what do we do there? Type it in chat. What do we do there? When I turn g of x on, what's it going to do? What's it going to do to the green graph? Okay. Okay, good. I'm seeing some people pointing in the right directions here, but I want some numbers on it. Be more specific. What's going to happen to f of x? I want to know it's going to get moved this amount, to the right or the left, and this amount up or down. Be specific. Okay, I'm seeing a prediction there. Right 3 down 4. Right 3 down 4. Right 3 down 4. A right 9 down 4. A left 3 down 4. Let's get some more votes here. Left 3 down 4. Okay, let's think about this piece by piece. So it looks like I did two things. I added 3 to x inside the function, right? Inside the function, I added 3 to x. What should that do? Inside the function is the backwards one, right? So adding 3, it actually doesn't move it right. It moves it left that amount, doesn't it? And then outside of the function, I subtracted 4, so that should go down. So it should go left 3 and down 4. Let's check it out. Yeah, it did it, didn't it? Right? It did it. Okay, so let's see. Right? Look what it did to the vertex. The x coordinate got 3 smaller, and the y coordinate got 3 smaller. So it went left 3 and down 4. Okay, let's try again. Let's try again here. So I'm going to make a new one here. I want you guys to tell me what's going on. Let's do quantity x plus 1 squared plus 5. Okay, tell me what's going on there. Let's get answers from everybody on this. Getting lots of left 1 up 5. Lots of people saying left 1 up 5. Everybody's got to contribute. I should be getting 1, 2, 3, 4, 5, 15. I should be getting 19 answers on this right away. Okay, I'm getting lots of left 1 up 5. Let's try it. Yeah, it looks good. Left 1 up 5. Look what the vertex did. It went left 1 up 5. Okay, let's try one more. Okay, let's do the quantity x minus 2 squared minus 3. Oh, darn it. There we go. What's that doing? Quantity x minus 2 squared minus 3. Yeah, okay, we got it. Right 2 down 3. That's correct. Okay, x We subtract 2 from x inside the function, goes right 2. We subtract 3 outside the function, goes down 3. Very good. Okay, I think you guys are getting this. Good stuff. Okay, so this is shifting us. The number we subtract from x tells us how far we're going to the right. That one's the opposite. And the number we're adding outside tells us how far we go up. Okay, next issue, dilations. Okay, let's see what happens here. What happens if I multiply a function times a number outside of the function? So for example, let's take a look at this one. So if I've got my absolute value function here, right, I'm going to multiply my absolute value function times a. Okay. What if a is 2? So I'm going to graph the function f of x equals 2 times the absolute value of x. What's that going to do to the function? Try to describe it for me. Make your guess. Well, we haven't learned this yet, so this is a guess. What do you think that's going to do? Type it in chat for me. What's that going to do? Okay, I'm seeing the angle is going to get bigger. That's one possibility. Anybody else want to make a guess on this? Angle, okay, what Noah said, so it could get, angle could get bigger. Anybody else? Let's try it. Let's see what happens. So if I let a equal 2, everybody's hearing a drum roll in their head right now. There it is. Oh, what did it do? That's how it changed the function. Well, it might help here if we add some points to this. Okay. How would you describe that? What did it do? When I multiplied the function by 2, look at all the x coordinates. The x coordinates of these points that line up vertically, they all stayed the same, didn't they? Right? But look at the y coordinates. Started at 0, ended at 0. Started at 1, ended at 2. My original y coordinate was 2. I ended up with 4. Original was 4. I ended up with 8. What did I do to all of the y coordinates when I multiplied the function by 2? What do you think? What did I do? Yeah, I just multiplied them all by 2, didn't I? Right? I multiplied them all by 2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, right? Multiplied them all by 2, okay? So that stretched the function out, right? It stretched the height of the function out by a factor of 2. Instead of going 1 to the right and up 1 on my new function, if I start at the vertex and I go 1 to the right, I had to go up by 2. I used to go right by 2 and up by 2 with my parent graph. Now if I start at the vertex and an ant walks 2 to the right, he goes up by 4. So the function got stretched by a factor of 2. Okay, what do you think is going to happen if I make that value of a 1/2? What do you think that's going to do to the shape of the graph? So when a was 2, it stretched it by a factor of 2. What do you think is going to happen if a is a number that's less than 1? It's between 0 and 1. Okay, I'm seeing some people that are signing here. Noah's telling me that it's going to squash the function. Instead of stretch it, it's going to squash it vertically. Anybody, you guys going to go with that? What do you think? Give me some answers. You willing to go with Noah's prediction? Let's go with Noah's prediction. See what we get. So if I'm multiplying the function by 1/2, yeah, look what it did. It squashed it. And if we put the points up there, it makes sense. It really did the same thing as before, right? It took all of those y coordinates and it multiplied them by 0.5. So we used to have a y coordinate of 0. Well, 0 times anything is 0. So that one stays put. But look at this point right here. We used to have, when we went right by 1 on our parent graph, We used to have a y coordinate of 1, but now we multiplied that by 0.5 and we got 0.5 for our new y coordinate. We used to go right from the vertex by 2 and go up 2, right, on our original parent graph. But now we're going to multiply that y coordinate by 0.5. 2 times 0.5 is 1. Yeah, so it made each of these points on the absolute value function only half as high. Squashed it down. It compressed the function by a factor of 2, or a factor of 1/2, right? Multiplied everything by 1/2. Okay. So then if a is a number bigger than 1, if the absolute value of a is greater than 1, so it's a big number, I'm going to stretch it by a factor of a. I think I got to fix this one. I think I have a mistake here. If a is a fraction that's less than 1, between 0 and 1, then I got to fix that. It's going to compress it, not stretch it. It's going to compress the function by a factor of a. Okay? All right, so what happens if it's negative? Let's take another example here. So we said that if a is positive 2, it stretched it. We multiplied all the y coordinates by positive 2, right? Which stretched it up vertically. So my question to you is, what do you think is going to happen here if I make a negative 2? Make a prediction. What's that going to do? If I multiply a, if I multiply the function by negative 2, so a is negative 2, what do you think that's going to do? How's that going to change the look of the function? I'm not getting any answers. I'm going to have to start asking some questions here. What do you think on this one? Olivia, what do you think? What's your prediction? If I multiply that green parent graph by negative 2, what do you think it's going to do?
Will the lines go below the...
Let's try that. Will they go below? Let's try that. Hey, there you go. Look at that. Okay, that makes sense though, doesn't it, right? Because what we do, we multiplied our parent y coordinates by negative 2 to get our transformed. Really, we'll call this dilated. A is what we call the vertical dilation factor. Remember in geometry, you might remember talking about transformations in geometry, right? So we had 3 what we called isometric transformations in geometry. There were 3 things we could do to any geometric shape, and it would transform it, but it wouldn't change any of the measurements. It would stay the same size and look the same, right? We could translate it and it still looked the same. It just got moved around. We could rotate it about a point, but it still ended up having everything looked the same on the object. Nothing increased or decreased, right? It still looked the same. Or we could reflect it and still stayed the same size. But then we had a different kind of a transformation called a dilation in geometry. Remember doing that? If you dilated something, it either blew up uniformly, right? Like we inflated it uniformly, so it grew uniformly, or it shrunk uniformly, right? It had the same shape, but just different size when we dilated it. Well, what we've done here is something sort of like that. We vertically dilated it, not horizontally. The horizontal values of all those points stayed the same, but the vertical values got changed, right? So when we have a dilation factor of negative 2, when I multiply those regular heights by negative 2, it makes those positive values negative. For example, the y coordinate 1 times negative 2 gives me the new y coordinate here of negative 2. The y coordinate of 4, normally I'd go over 4 and up 4, but now I'm going to go up 4 times my negative 2. 4 times negative 2 is negative 8. So I go to the right 4 and I go up by negative 8. Going up by negative 8 just means I'm going down by 8. There it is. Everybody see that? What if I make a negative 1? Well, then it didn't get stretched at all. It just got reflected in that case, didn't it? Right? If I multiply all these y coordinates by negative 1, they just become negative. So effectively, all I did there is just reflect it over the x-axis. Okay? All right. What if okay, never mind. I think we're good there. So if I put a negative sign out front in addition to stretching or compressing, that's going to reflect it also, right? Okay, we can put all this stuff together at once, A, H, and K, and here's what it looks like. The parameters A, H, and K transform any parent function. It could be absolute value, could be quadratic, could be square root, could be anything. They transform this parent function to create a new function, f of x equals a times p of x minus h. So h is being subtracted from x inside the function, plus k outside the function, where a is the vertical dilation factor. It also tells me if it's a reflection, if it's negative. H represents the horizontal translation, and K represents the vertical translation. Okay, so I want you guys to make a prediction for me then. Let's see, I'm going to do this a little differently. So I want you to tell me what's going on. There's my parent graph. Okay. Okay. Oh, darn it. I'm going to start again. Everybody tell me what I'm doing there with f of x. What's it doing to my parent graph? Type it in chat, please. Got one answer. I need 18 more. Make a guess here. Okay. Okay, compress. Okay. Okay. These all look pretty good. Let's try it out and see what happens. Okay, what did it do here? Yeah, so I want to be able to put the points on there. So that's going to be, so what did it do? Yeah, okay, so people were saying it went left by 3 and up by 4. That looks good, right? It seemed to do that, right? There's my points. And look, the x-coordinate of the vertex here is -3, +4. Okay, the other thing people said was it was compressed or flattened out. It was, but by how much? The dilation factor is 1/2, so it should only be half as high at each point as it normally would be. Let's check it. So normally I would go over 2 and up 2, but now I should only go up half as high, right? So if I go from the vertex here, and let me set this up so we have steps are 1. So we can count these more easily. There, that's good. So now from the vertex, if I go over 2, I should go up only half as high as I normally do. Well, 1/2 times 2 is 1. Yeah, it worked, didn't it? Right? Normally, I would go over 4 from the vertex to the right and up 4 to my function. Here I go 4 to the right and up 2. So it worked. It flattened it out so it's only half as tall, right? Okay, let's try one more of these. Oh, okay, I know it. Yeah. Okay, let's try this one. Tell me what's going on here. Okay, tell me, what did we do there? How is f of x going to transform my parent graph? Everybody type it in chat here. Test yourself out. Okay, everybody's got an idea maybe? Let's check it out. So let's take these one at a time. Subtracting 2 from x inside should go right 3. Okay, I like that. Adding 4 outside means it should go up 4. If I multiply the function by -3, that means that I'm reflecting and stretching by a factor of 3, aren't I? Because I'm multiplying all of the normal heights by -3. So they're going to get flipped and stretched, correct? Let's see if that works. Let's try it. Okay, I got a, let's see. So this is going to give me, that's a -3. That's a 2, and that's a 4. So there we go, right? Let's look at those points and see if it did the stuff it was supposed to do. Okay, so it looks like, yeah, we went right. The vertex went right 2 and up 4. Check, check. Now, what about the heights? Normally, if I go 1 to the right on my green parent graph, I go up by 1. I'd have to multiply my normal height by, whoops, that's supposed to be a -3. There we go. Okay. So I'd have to multiply my normal height here by -3. So instead of going to the right 1 and up 1, I'm going to the right 1 and up 1 times -3. I'm going up -3. Is that right? Let's see. From the vertex on my red graph, I go right 1 and I go down 3. Yeah, that's up -3. Normally, I would go to the right by 2 and up by 2. I've got to multiply that height by -3. So now I'd go right 2 and down 6, right? There's the vertex. I go right 2 and I go down 1, 2, 3, 4, 5, 6. Bingo. It did that. Okay. Everybody see that? Okay. I think that's a pretty good place to stop for today. Everybody give me a 1 to 5 on that. It's, I doubt there's going to be a lot of 5s. There might be some, but there's a lot of stuff I just threw at you. But are you kind of making sense of that a little bit? What A, H, and K are doing? You can either flash me fingers or just type it in. Okay, good. All right. So I'll put the assignment up for 3.2 practice 2, but we've got a lot more to talk about next time. So if you want to get started on it and just get a little practice to kind of iron in the stuff we talked about today, I'd kind of recommend that. Do at least a couple problems, but we'll come back to this on Thursday and do a bunch more. All right. Have a great day. I will let you guys go here. I'll be here after school if you need me. Otherwise, I'll see you on Thursday.